Balance. Do the same thing once to both entire sides of an equation. Two opposite sides, one effect. This is the complementary operation or action to big small. It works on one side only, and it has two effects. Big small never crosses the equal sign. It can work even when there is no equation. Balance only works with an equal sign, and it always works with both sides at the same time. It is something that must be maintained. The value on the left must always equal the value on the right. The values may change from step to step to step, but the values of the left must always equal the values of the right on that line. So an equation is like a weigh scale, usually with a known amount on one side and the unknown weight of your object on the other side. We know the weight only when it balances. So if you've seen those, like the scales of justice and the blindfolded lady holding it, if you put 5 pounds on the right and you keep adding unknown weights on the left, when it finally balances, then you know you got 5 pounds on the left, because right equals left. And that's what we must always maintain in our equations. I'm going to give you a few examples here, but we'll have plenty more examples as we look at equations themselves. So I'm just going to introduce here, but it'll be all the basic moves. I just don't need a lot of examples because I'll have a lot more later. Okay, so the equal sign tells us the equation is in balance. Our job is to keep it balanced by changing one side, then making an equal counter change on the other side. And how I want to do that is to show you the shortcut. I'm not a big one on memorizing all these things, but I have noticed with students that this shortcut pays. When they take the long way around, and I'll show you the long way around on some of these examples, they start making it a step and an end in itself. And the more they write, the more they miswrite, and they make typos, and they make mistakes. And of course, they're going to get the wrong answer. So if someone understands the long way and they're doing good with it, fine, I leave them alone. But if they can't get it right and they keep making errors, I'm going to move them over to this way. So here's our equation here. 2/7 x equals 9. Now, I want to find x, so that 2/7 is in my way. What do I do to get rid of that 2/7? Well, it's 2/7 times x. So I'm going to have to multiply or divide to break that 2/7 factor away from the x. We're dealing with fractions. Obviously, I want to times, so I'm going to multiply by the flip of 2/7. And now you can see 7 times 2 is 14. 2 times 7 is 14. 14 over 14 is 1. 1x is just x. But can I just multiply by 7/2 on one side and then call that good? No, as soon as I introduce that 7/2, I'm changing the value of the left, which now means it is out of balance from the right. So what do I have to do on the right? Well, do the same thing once to both entire sides of the equation. And the entire side, of course, here is just a 9. So both sides have been multiplied by 7/2. They cancel out on the left, and I'm left with x. 9 times 7 is 63 on top. 1 times 2 on the bottom, 63/2. There's my answer. And again, as I tell students, without instructions, if it's a fraction problem, give me a fraction answer. So I am just going to leave it. I never ask them to change it to whole numbers. I mean, when there's a unit on it, sure, we'll do it for a little bit. But algebra likes improper fractions. Okay, over here, 5x equals 15. Now, how come I'm not dividing by 5 on both sides and showing all that? Well, you know what's going to happen. Why bother writing it over here? The reason you're dividing by 5 is because you got the multiply by 5 there already, and you know that's going to turn into a 1. So what is the point of doing something you already know except to possibly make a typo? So skip it. This is why I call it opposite operation, opposite side. I am implicitly 5 divided by 5 is 1, and I'm doing that down there. 15 divided by 5 is 3. Opposite operation, opposite side. I'm in balance. I'm doing the same thing to both sides. I'm just not writing it out. It's pointless. And notice, if we say x equals 3, look at my value all the way through. If x is 3, 5 times 3 is 15. 15 equals 15. X equals 3. 3 equals 3. On both lines of the problem, left equals right. The lines have different values. That doesn't matter. But on each line, left equals right. 15 equals 15, 3 equals 3. And that's how you check your equation as well. You take your answer, go back, and you can go to the first line, is usually all we do, but you can put it in every line and see that you are maintaining balance all the way down. Here's another example with a little more complicated equation. I'm not going to get in the particular steps why we do what we do. Is just the important thing is that balance is being maintained. So I start with some decimals up here. And so I need to multiply both sides by 10 to get rid of the decimal. So I introduce parentheses. I'm going to multiply both entire sides by the same amount. And I don't know what x is. I don't know what x is, but I know they're the same. And I know when I add 1.4 plus 6x, whatever that is, it equals 0.2 minus 3x, whatever that is. They equal. So if I multiply two equal values by 10, both of them are going to be 10 times bigger. Both of them will still equal each other. I maintain balance, even though I don't know what x is. So I do my multiplying by 10, and I come down here. So now I want to get letters left, numbers right, because I'm trying to get x equals. So I want this 2 to move over there, and I want this 60x to move over there. Well, again, I can do all my minus 2 and adding and all that kind of stuff. Yeah. It's all for typos. It's good to do that a few times. It shows understanding, and it shows you're doing the same thing to both sides. Don't get me wrong there. It's good for the basic understanding at the beginning. But after that, yes, I'm a believer in the shortcut in this case because the number typos and the tediousness. They know the 2 is going to move over. So you don't need to keep rewriting and rewriting. Just move it over. But switch the sign, because these are terms. This is all adding and subtracting. This is a special case of opposite operation, opposite side. By switching the sign, I'm switching the operation. I'm adding 2 on the left. Now I'm subtracting 2 on the right. I've also subtracted 2 on the left because notice it disappears. You don't see the 2 over here. The same thing is going to happen with the 60x. It's going to disappear from the right, which means I have invisibly subtracted 60x. And now subtracting 60x shows up on the other side. Opposite operation, opposite sides, switch signs. It's all part of balance.